So now we are going to start 10th unit of crash course, which is current electricity. You know from 10th class what is current. Current means rate of flow of charge. If you are developing a potential difference across a conductor, to overcome this potential difference, charge flows from high potential to low potential. Since electrons are flowing, so they will move in actual from low potential to high potential to make it low. But for our convenience, we are taking the flow of current against the electrons flow. It means if I am connecting one battery between these 2 points, it will develop a potential difference across these 2 points. So electron will start flowing from negative terminal to positive terminal to reduce the potential of high potential point. So we will say that current is flowing from this point to that, because we are saying current is rate of flow of positive charge. Now what will happen when current flow in the conductor, but there is not an empty space? There are many others atoms and ions from which electrons separated. They will come on the way. There are collisions. So what we are saying, between two collisions, electron suppose is moving from this point to this point in this way. It is colliding with one another electron or atom. Distance travelled between two collisions, and to cover this distance, time taken is known as relaxation time. Generally we are denoting it by tau. You know that when you are applying a potential difference across the ends of conductor, you are developing one electric field, and electron will experience a force due to this electric field in the opposite direction of electric field. It means this force will develop one acceleration. If after one collision its initial speed is 0, again it will get that speed in this time. So we know that from Galileo's equation, Vd is equals to u plus at, means minus ee tau divided by m. This velocity is known as drift velocity. It is known as drift velocity. It is in the opposite direction of electric field. And current per unit area is known as current density. Current per unit area, it is known as current density. And you can also calculate current by rate of flow of charge. If you know the speed, in 1 second how much charge will enter in your that specimen, so easily you can get NAE Vd. What is N? N is electron density, means number of electrons in per unit volume. Number of electrons in per unit volume. We know that in 1 second electron will travel a distance equal to its velocity, and area of cross section into velocity is a distance is volume. So the volume in which electrons enter in 1 second is this. If in per unit volume there are n electrons, in this volume number of electrons should be this multiplied by n. In one electron, if there is E charge, total charge entered in this volume in 1 second is this. By the definition, it should be current. So we can write current NAE into VD. A is the area of cross section of your specimen. VD is drift velocity of electrons. A is area of cross section and electronic density. E is charge on electron. You know that when you did the derivation in your 12th class, what you find? You find that resistance was ME, M upon NE squared tau into L by A. In derivation, we find this expression for resistance. What you can observe in this relation? What was M? M was mass of electron. N was electronic density. E was electronic charge. Tau was relaxation time. L and A were length and area of cross section of specimen. So in these things, M, E square and tau, it depends upon the metal which you are using as conductor. Because if you are using silver, there are so many free electrons in per unit volume. But for aluminium, this number is little less. So N vary from metal to metal. M and E are constant for all metals. Tau, relaxation time, depending upon the physical conditions. Relaxation times means collision between two, time taken between two collisions. But L and A, they are purely related to your specimen. So what we are saying, कि if we are not going to change the metal, this term should be constant. For different specimen of same metal, L and K can be differ, but this should be constant. So we are giving this term a special name. It is resistivity, which is constant for particular metal, and E squared tau. It is resistivity. So we are denoting this by rho. What is the unit for this resistivity? You know that unit for R is ohm. A means meter square and this is meter. 1 meter will cancel out and send this meter on this side. So the unit is ohm meter. Ohm meter. The reciprocal of resistivity is known as conductivity. So it means for particular metal, R is directly proportional to L over A. By doubling the length, you are doubling the resistance. By doubling the radius, you are making resistance 1/4. So in this way, they can ask some problems in NEET based on these concepts. How they can frame the problems? See, we have one specimen in the form of a wire whose resistance was R. I stretch this wire to double its length, means by stretching I make the length double. What should be the resistance now? If simply you will say yes, R is proportional to L, so it should be 2R now. No, you are wrong. What we are doing? We are stretching the wire. Material is same. So wire will become thin. Means area of cross section is also changing. Since volume is constant, So if initial area of cross section was L, initial length was L, new area of cross section is A dash, new length is 2L. It means new area of cross section is half of the old area of cross section. So new resistance should be, what was old resistance? If old resistance was rho L by A, now new should be, material is same, you make L double, A become half. Means we are getting 4 extra. So 4 rho L by A, it means resistance will become 4 times. I am giving you one short trick. You can remember that if by stretching you are making length n times, so resistance will become n square times. If you are making length by stretching n times, resistance will become n square times. It means now if they are saying we stretched a wire and make its length 5 times, what should be new resistance? Resistance will become 25 times. Getting my point? So remember this. And in 10th class, we have these derivations. If we are going to add a resistance and to end, means series combination, the equivalent resistance you will get by the formula R is equals to R1 plus R2 plus R3, R1 plus R2 plus R3. But if you are connecting the resistance like this, means one end at one point, another end at another point, the equivalent resistance is given by 1 upon R is equals to just opposite results what you got for capacitor. 1 upon R2 plus 1 upon R3. Parallel and this type of combination, series. What is constant in series combination? What is the total current? It will pass through each resistance. Means total current in a series combination should be equal to current through each resistance, but potential difference will be divided in 3 parts. Total potential difference will divide in this case 3 parts. Means V will equal to V1 plus V2 plus V3. What is happening here? Here current is dividing in 3 parts. Means each resistance is receiving different currents. But potential difference is same. And what is the total potential difference? Each resistance will get same. In this, total resistance is dividing into 3 parts. In series, total potential difference is dividing into 3 parts. So many type of problems they can frame. Maybe conceptual, maybe calculation, they can use the series. So remember one result for series. In a series, 3 types of series are there. AP, GP and HP. Arithmetic progression, geometrical progression and harmonic progression. Since arithmetic progression was in 10th class, so I am not discussing about that. But remember that this type of series is known as geometrical progression, in which ratio of 2 consecutive terms is constant. If this ratio is less than 1, you can add this series up to infinite, and sum of infinite GP is GP, geometrical progression, and sum of infinite terms you can calculate by the formula A upon 1 minus R, and for n terms it is A into R raised to the power n minus 1 upon R minus 1, a useful result. Sometimes without series, only by using the symmetry we can solve the problems. See, I am showing you what I am talking about. Suppose we have a structure like this. And this is going up to infinity. It is going up to infinity. And they are asking you, calculate the total resistance between A and B. Total resistance between A and B. How to solve this? All resistance are of R ohm. All resistance are R ohm. What should be the total resistance? Your structure is symmetrical. If we remove its one component, what I am saying, if we are removing one component, see your structure from this point. If I shift A to this point and B to this point, again the problem is same. If in infinite portions you are removing one portion, infinite minus 1 is again infinite. So if we are saying that total resistance is X, resistance from this point means resistance after this, it should be X. So it means I am saying that resistance of this R, it is R, it is R, it is A, it is B. If total is X, from this total circuit should have resistance X only. Now this X and this R are parallel. So what I am getting? R. We know the formula for parallel. Add this by parallel. Product divided by sum. So it will become A, B. It will become Rx by R plus X. Now these three are in series. Total we said X. So X should be equal to 2R plus Rx upon R plus X. So what we are getting? We are getting X into R plus X is equals to 2R plus Rx. Means X square Rx, this R plus X I took on this side. See, multiply the whole equation by R plus X. What we are getting? X into R plus X, and it is 2R into R plus X plus Rx. So square x square only there. This Rx will cancel with this Rx. Take this 2Rx on left hand side. And after that this 2R square take on left hand side. It is a quadratic equation in x. So we will get two values of x. Minus b plus minus root of b square minus 4ac to a. It is 12r square, take r common, it will 12 means 2 root 3, cancel 2 with 2. So what we are getting, x is equals to r. Not taking minus sign, resistance cannot be negative, so I am ignoring this minus sign. I am ignoring this minus sign. So it will become 2 root 3, 2 is cancelled out, so it will become root 3r. So I got the total resistance. So in this way we can solve it. Now next, many times they are asking a problem based on color code. Means they will give you a specimen. They will give you one specimen on which there are 4 strips. Of different colors. 1, 2, 3, 4. We will solve in last. Suppose they are saying it is yellow, it is violet, next one is brown, and last is golden color. They will say decode the resistance of this resistance. Decode the resistance of this specimen. How to solve this type of problem? Remember one list. And not very tough, I am giving you a trick. B. Roy. 5 colors are there. B. Roy of Great Britain. Of Great Britain. Very good wife. C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the first letter of 10 different colors. Black, brown, red, orange, yellow, G for green, B for blue, violet, grey, and white. They are associated with one digit: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. First two colors will give you, first two color will give you the first two digits of the number. Third color will give you power of 10 and last color will give you tolerance. Tolerance for gold, silver and no color is 5%, 10% and 20%. See, now I am decoding the resistance of this specimen. First color was yellow. Yellow stands for 4. So I am writing 4. Second color is violet. Violet stands for 7. So I write 47. Into 10 to the power. Third color was brown. Brown stands for 1. Plus minus tolerance is 5%. So it is the resistance of this. In ohms means 470 plus minus 5% ohm. So we are getting this. So remember this code. Maybe you will get one problem this year. B.B. Roy of Great Britain, very good wife. First two color will give you a 2-digit number. On 10th place, you have to write digit associated with first color. On unit place, you have to write the digit associated with second color. Into third strips color will give you 10 to the power and fourth strips color will give you tolerance. So it was all about resistance, and temperature effect on resistance is very simple. If you increase the temperature, number of collision will increase, so resistance will increase. RT is equals to R0 into 1 plus alpha T. Alpha is the coefficient of temperature, coefficient of resistance. So it was all about resistance, and now we are going for heating effect. We are going for heating effect. When current is passing through a resistance, you notice that the temperature of resistance will increase. Why? Energy developed in that resistance. We know that energy is equals to work done, and work done is equals to V into Q. And what is the relation is V? V is Ohm's law, studied in 10th class, I into R. Remember always, the substance which are following the Ohm's law means graph of V and I is a straight line, are known as ohmic resistance. V is equals to IR is valid for all, but if they are not, a graph is not a straight line, then they are known as non-ohmic resistance. So V is equals to IR into Q. Q is again I into T. So it means heat developed in joules is equals to I square RT. If I in ampere, R in ohm, T in seconds. Or you can convert this by dividing the value of J, 0.24 I square RT. It was in joule, now it is in calories. But I should be in ampere, R should be in ohm, T in second. Again you can get one more result. It is work. energy. Write QV into Q means IT. Take T in denominator of W. Work upon time, you will get power. What power you are consuming, you can calculate by this result, V into I. What power you are consuming in your homes, that energy they are counted in one different units. That unit is known as kilowatt hours. kWh. What they are saying? That unit is known as kWh. Kilowatt hour. 1 kilowatt hour means, kilo means 10 to the power 3. Watt means joule upon second. 1 hour means 3600 second. Cancel second with second. So what we are getting? 3.6. 3 zeros here, 3 this. Into 10 to the power 6 joule. So what energy you are consuming for domestic purpose, that is counted in kWh. 1 kilowatt hour means when you are consuming 3.6 and into 10 to the power 6 joule, electricity board will say you consumed 1 unit of energy. They will charge for it. If you want to calculate your bill, number of units, you can count by this. Number of units means watt into hour divided by 1000. It means, suppose in your city rate of electricity is 10 rupees per unit and it is the month of April. You are using only one fan of 50 watt. Daily 10 hours. One bulb of 100 watt. Daily 6 hours. What should be your bill? See, first I am calculating unit for fan. For fan, how many unit you are consuming in April month? Watt is 50. And number of hours for which it is used, daily 10 hours. In April there are 30 days, means 300 hours. Divided by 1000, cancel these 30. So you will get 15. 15 units your fan is consuming. Bulb, watt. Wattage is 100 watt. Bulb was 100 watt. Daily 6 hours. In 30 days, 180 hours. Divided by 1000. Again cancel these 3 zeros. Means 18 units bulb is consuming. So total units 18 and 15, 33. 1 unit cost 10 rupees. So bill amount 33 into 10, 330 rupees. You can count like this.